And there's different things we're going to talk about today. Namely, we're going to talk about aesthetic. Sorry, I don't want that to be a header. I want it to be a bullet point. Aesthetic mappings. We're going to talk about, sorry, all of them have disappeared from my head, even though I type them all the time. Aesthetic mappings. We're going to talk about data. We're going to talk about geometric transformations, I guess I'll call them. And we'll also talk about facets and a lot of other kind of small things that will get covered today. There's a lot of information I'm going to cover today. It's all on the lesson on the class website. And there's infinite more information that you can learn online as well. So if after this class you're like, oh, I really want to make a plot where my label is a different font, you can find that on Google. I'm definitely not teaching anything about fonts today because they're a pain to learn and teach because they're dependent on computer system. So Google things that you don't know. The internet is a wonderful place for the R community. And now I'm going to teach you the basic function. So if you remember, we talked about in R, things look like function, parentheses. So with ggplot, we first need to load the tidyverse package. So we're going to type library tidyverse. We also want to load our penguins data set. So I'm going to type library Palmer penguins. And then finally, before we get plotting, we need to load the data. And this all should not be new because you did this last week. We're going to type data Palmer penguins. I'm going to run each of those lines individually by doing Control Enter. Tidyverse always takes like 20 seconds to load because it's loading a lot of things. You can see all of the things it loads where it says attaching packages. And then there are conflicts when it loads. So what this means is unless you write the name of the package you want and then 2 colons and the function, dplyr, this package will mask the stats filter function. It probably won't matter for a long time, but I'm just putting that in the back of your minds because you might eventually have a function conflict where you're trying to call one function and you're actually calling another. Okay, so we have the tidyverse loaded. Oh, and I have a chat here. Yeah, if you get a notification to install R tools, I remember, I think Raphael got that last week. I would just go ahead and install it. It takes like a minute or two to install, and it helps your computer compile the packages better. That's all I know of what it does. So yeah, go ahead and install it. So I loaded the Palmer penguins data set, which means now I can load.
That's what I was going to say. I think it's the penguins. That's the name of the data set.
Yeah,
I didn't get
they keep changing the name of this package. It used to be called penguins, then they called it Palmer penguins. So I think it's just penguins, like Raphael just said. And yes, that looked like it worked. So let's do a very quick exploration of what the penguins data set looks like. I'll just open penguins. I can do that by double clicking, for instance, and I can see there's a few different types of data here. So we have what's here is called a factor. We'll talk more about that, but that's basically a categorical data variable. So we have species, we have island, which is also a factor. So there's an Adelie species of penguin on the island of Torgerson. We have their bill length, meaning the penguin's beak, how long that is. The penguin's depth, which is how wide it is, or I can't remember if it's this way or this way for these penguins, but it's how wide it is in some aspect. We have how long their flippers are, how heavy they are, their sex, and the year that this recording was taken. This is the kind of data we're going to be working with today. And if you ever want to, as you're just exploring the data, you can also click this little arrow, which I don't think I showed you before, and you can see it all at once. Okay, now we can actually learn the basic ggplot function. All of the housekeeping. Okay, so the basic ggplot function, I'm going to type it. I'm going to actually break this box. So if you're ever inside of a box, you can do the create a new box function and it'll break the box into 2. And I'm going to say here eval equals false. which means don't evaluate this because it's not working code. So the basic function is ggplot with a parentheses. That's the most basic part. The first argument to this is always data. And anything I type in capitals, that's saying this is something that you can add your own specifications to. So data equals your data set, comma. And then the second part is mapping equals AES. So this part you can only change in one way that I'm sure I will cover later, but mapping equals AES. AES stands for aesthetics. So what are the different aesthetic mappings that we're going to do? Aesthetic mappings is basically how your variables are going to talk to the different systems that you're introducing. Within that AEX, there's a lot of things you can do, but usually you're going to have an X variable. You're going to have a Y variable. And you might have other things like color or fill, all of those things. So I'm just going to write color equals variable. So that's like the very basic part of a ggplot function, but there's one final thing you need, which is a plus sign. And then I always do a line break after a plus sign. We'll see that as these ggplots get more complicated, that's kind of a useful thing to do. You'll see that R automatically gives you a line break. And here we will have a geom underscore, I'm just gonna write type here. So this is like a very basic version of a ggplot. It's not working because we haven't actually included any variables or data that we want to pull from. But if you feel like this is something that is going to be hard for you to kind of memorize quickly, you can always add a snippet, which I'm not going to cover right now, but it basically is like a code you can copy and paste by typing one short command. And so if you want to do this over and over, you could add a snippet, but again, I'm not going to cover that. I'm just going to introduce that idea. So great, we have this basic ggplot function. Now we actually want to make a ggplot. So I first will teach you how to make ggplots with two continuous or two quantitative variables. Does anybody want to do a one sentence of what a continuous or a quantitative variable is?
It's a variable that's numeric, so it can be analyzed statistically, and it also isn't broken into categories, so you can have all of your variants.
Quantitative variables. So, for instance, I might want, I'm actually going to draw this on a piece of paper and show it on screen. I might want to make, oh, I forgot about this. If I put it in front of my face, you can, no, okay, that's not worth it. I don't feel like turning off the background. So if I want, let's say, two quantitative variables, the most logical way to do that would be an X, we'll have an XY axis, and then basically a dot plot in between, which would be called a scatter plot. So let's do that with the penguin data. So I'm not going to copy and paste this. You can copy and paste it, but I think it's good to repeat typing this out because you will type this out a million times in the future. So the data I'm going to use is called penguins. I'm going to do mapping equals AES. And if you wonder what just happened there was an autocomplete and I clicked tab to autocomplete it so I didn't have to type it out. AES, and here I actually want to look at flipper length versus body mass. So when I say that, I mean I want my X to be flipper length. And let me pull down my penguin so I can see how I spell flipper length, because for underlying reasons, it's not going to autocomplete these. Flipper length millimeters. And then for my Y, I want to look at bill length. I'm not following my lesson completely. And you'll see there, I didn't actually write Y equals, so I should write Y equals bill length. And then finally, I'm going to do a geom point. So what these geoms are is what type of plot I'm doing. So after the plus sign, I'm going to write geom underscore point parentheses. And let me run that. And you'll see in my plotting window, which is on the bottom right, I just built a very basic but working plot. So oftentimes when we're looking at something like a scatter plot, we're looking at how either is there a relationship between two continuous variables, or for instance, does one continuous variable kind of cause the other one? No like fancy causal evaluation here, but just like, does it look like flipper length is determining bill length? And we can see, yeah, there's somewhat of a relationship, but we might ask, and it looks like it's a positive relationship, but we might ask why, when I look at these, I kind of see these little clusters. I don't know if everyone sees these, but it looks like there's a clustering going on here. And so what I want to do is actually add on to this. So I'm going to keep editing the same basic function. I'm not going to like write this out again. So I want to add a color dimension to add a third variable to this plot. So because this is getting kind of long, at any comma in R or RStudio, if you break it, it'll keep it nice and aligned. So I'm going to break that between X and Y, and I'm going to create another comma here, and I'm going to say color.
Wait, can you repeat how you break it?
So I just clicked enter on my keyboard, and it will keep it nice and aligned. And then let's say I did something funky and this is what I end up with and it looks terrible. RStudio will automatically clean that up if you do Control I. Yeah, Control I on Windows, which would be something else on Mac. So I want to actually look at this first I'm going to look at it by island, and then I'm going to look at it by species. So my island variable is just called island. Now island, I said, was a factor variable, which I explained was categorical basically. So this means that there's only 3 different types here, and this isn't continuous. This isn't something that like we could put on an x-axis and have it be from like 0 to infinity. So if I put it with island, we can see, okay, there's 3 islands. There's Bisco, Dream, and Torreson, and it kind of works. It kind of gives you some clustering, but let's try our second variable instead, which was species. So if I want to put species into here and have these dots colored by species, what would I edit of what's currently in the code?
What you wrote after color.
Perfect. So I want to map species onto color. So let me run that and see if that kind of explains it a lot better. And I think that explains it really well. It looks like Gen 2 penguins have longer bills, longer flippers, but there's internal variation. Chin strap penguins have longer bills, but shorter flippers, about the same length flippers as Adelie penguins, which have pretty short bills and pretty short flippers. You can always Google pictures of these penguins. I'm not going to take time out of class, but they're very cute. So I think this actually looks pretty nice. We can also map this onto shape. So if I want to add another aesthetic, I can do another comma and type shape. Makes sense that shape would be what you would use to do shapes. And so I'll also do shape by species. And I'll run that. And we can see that there's now 3 shapes. There's a circle, a triangle, and a square. And it just differentiates these dots a little bit better. Now, what if I wanted to instead of mapping shape onto an aesthetic? So remember, when we're mapping an aesthetic, it's mapping it onto a variable. If I wanted to just make all of these square, I actually wouldn't put it in this block. So I'll show you what I would do instead. So instead of putting it in this aesthetic, this is the global aesthetic part. I don't want it there. I actually want, for Geom point, I want the shape to be square. So I would type shape here instead. And then I can't remember the code for square, so I'm going to look that up in a different window. I just have a quick link on my computer that, can you all see this? Yes, okay, great. I couldn't remember if I shared my screen. So I just have a quick link that has this image here, and I want a square. So I'm actually going to type shape equals 15. And if you ever want to see that exactly, you just Google ggplot shapes and it'll come up. So now you can see they're all square. So the difference here was instead of having it as an aesthetic, aesthetics are mapped to variables. I didn't want an aesthetic. I wanted all points to have the same mapping. Well, not mapping. Let's not call it mapping. That'll be confusing. So I'm going to leave that there and just keep building on this now. Let's say instead of having color by species, let's say I wanted it as a continuous variable. I can also map a continuous variable. Color can have many scales that go, you can have a color from like black to white. And so I could do a continuous variable here on color. Let's do body mass here. And you can see now we have a legend instead of about species or island, we have a legend of body mass, and we can see darker colors indicate smaller body masses and lighter colors indicate higher body masses. And it's quite actually clear in the graph that flipper length and body mass and bill length are all kind of like related to each other. But if I wanted instead to put that to a shape, you can see I get an error, and that's because we have a lot of different body masses. As Sydney said earlier, body mass is a continuous variable, and there's very little kind of like defined stops, and it's not a binned variable. So there's too many optional values for it to be mapped onto a shape. So I can't map it to a shape. I could, but that would be a lot more complicated. So I'm going to change that back to color and put my shape back in here. So let me just undo. And then show you one other thing that you could map. So I could then map size onto my points. So if I wanted size to be determined by body mass G, I could run this here and it looks quite nonsensical, but you can kind of see that there are smaller dots and bigger dots that indicate that both color and body mass, both color and size are determined by body mass. One thing that you'll notice here is that we lose a lot because some blocks, can you do a 3D plot? Yes, you can, but as you can imagine, 3D plots are a lot harder to read. So you usually have to do an interactive visualization where you can actually move around the axes to explore it. I'm not going to be teaching it today, but it's actually not very difficult to do. It's basically the same code, but you just need another package to be able to allow you to interact with it. But I'll show you other ways to add in a third variable, for instance. Like this is one way. What was I saying? Okay, so because we have different blocks, different of these squares blocked by each other, you're kind of losing some of it. So what you could do also is create a Geom point alpha system, which alpha is basically standing for transparency. So a lot of people, they'll just call it alpha transparency so they can remember that. And this is a value between 0 and 1 of how transparent you want your blocks to be. If you've ever worked with something like Photoshop, this should be kind of familiar. And if I just do 0.5 and run this, you'll see that my blocks now are transparent and overlapping. That's one way to get rid of something that we call overplotting, where different points are plotted on top of each other, so you can't see actually what's going on. But let's say I did something like map my alpha onto a variable. So instead of setting it to a specific value, I'm setting it to a variable so that it varies along that. You can tell very quickly that this quickly becomes nonsensical. Like there's too many things going on in this plot. And I wouldn't say this plot is very useful because you don't know what you're looking at. And both the author and the audience don't know how to read it. And so this is what we would call, I just forgot. Something like cognitive fatigue. I don't know, one of the psychologists in the room could help. But basically there's too much going on and you're not guiding the person who's looking at the plot into what you actually want to show them. It's just a lot of different shapes and colors, etc. And it would be even worse if I said, oh, size equals species. Yeah, the more mappings you add, the worse it is for your you could call it your customer, whoever you're building your visualization for. So I'm going to right now kind of simplify this a little bit. So we can leave alpha here. We can leave alpha at 0.5. I'm going to remove it from the aesthetic mapping. And then I'm also going to remove size just because I didn't feel like that was useful, but I'm teaching you all different tools to use. So another important thing to get rid of overplotting, if you remember I talked about overplotting like 10 seconds ago, is called jitter. So I'm going to create a different plot right now just to show this a little bit better. So we have data equals penguins. We have mapping equals AES, X equals, and this time I'm going to do X equals year because it's a continuous variable, but it is binned in a sense that there's specific breaking points. Y equals bill length, and then color equals species. So you can see here, you don't have to break it at every time. I just break it when it gets too long. And then we have a plus sign to indicate something else is coming next. And we're going to do geom point. So if I run this, you can imagine because I said that year is binned, that there's only basically one value, there's no in between values, this plot is incredibly hard to read. So if instead of doing geom point, I'm going to comment that line out. You can comment doing Control-Shift-C or just put a hashtag in front of it. I'm going to do something called GeomJitter. And I need parentheses to indicate that that's a function. And you'll see that when I do GeomJitter, it basically adds random noise so that you still have the same sense of where things were in the plot, but you can see them a lot better. It deals with overplotting. It does add random noise, so you have to realize that those are jittered points, that this wasn't measured in 26.5. It was actually measured in 2007. Yeah, great. Thank you, January. And so that's one way you can get over overplotting. And another way, which this isn't a wonderful example, but I'm going to put this in a new line, is called Geom hex. So Geom hex, what it basically does is it says plots are not going to work well, or sorry, points are not going to work great for my data because I have way too many data points. Let's say you have next to 1 million data points in your data set. We only have 344. If you have 1 million, this plot would look ridiculous. So what Geom hex does, it basically, if you've ever worked with histograms, which we are going to later, it bins things together into similar X, Y values and says how many are in each bin. So to explain that a little bit better, this doesn't look great. I'm going to change this to FlipperBill just so you can see it better. Okay, so you can kind of see this better. Basically, we have the outside color of the hexes are still species, but the inside color are actually representing how many, like what count is in each of these cells. So in this instance, it's not super useful, but in many of your data projects, this may be extremely useful to represent, let's say, country GDP by like mortality rate, something like that. You would have a lot of values and you would want to see these like concentrated points. So that's just one other way to get over overplotting. So I'm going to say here, jitter and hex. That's an and sign, not a. Okay, I'm going to jump back a little bit and keep working on this plot here. So let me open it back up. Let's say, you know, I really like this plot. I think it says something important. Maybe I want the size a little bit bigger. If I want the points to be size 2, instead of being determined by a variable, I just want all of them to be size 2. I can make them a little bit bigger by putting them within the geom point parentheses. And now let's say I actually want to add a regression line. So I'm going to change this also. I'll just remove this for now. I want to add a regression line. I think a lot of us here have had the statistics to understand what a regression line is, but in very basic one sentence description, a regression line would basically be a line here that would exemplify the average relationship among all of these points. So because I mentioned earlier that this looks positive, a regression line would be something like, let's say like that. If it was straight, that would probably be an OLS regression line. But by default, when we add this regression line by adding a new geom, it's going to be something called low-S regression, which is LOESS, which has its own issues. But we actually have to draw the line. So if I pull this up, we have just our basic black ones. Yes. So to add a regression line, I'm going to add a new geom. So you'll see I had a plus sign here, and I'm going to add another plus sign here at the end of geom point, because I'm going to add another thing to this plot. So I'm actually going to add another geom, and this is going to be called geom smooth. So as I described the regression, you can kind of imagine that this is basically a smoothing line to condense all this information down. So if I run this, we will see a squiggly line because, there we go. We'll see this kind of squiggly line because this is a low-S trend line. Low-S is just a fancier version of it, and it has issues with overplotting, or sorry, overfitting, if that means anything to you. If it doesn't, that's okay. Generally, what we would want, though, is to do an OLS line. So if I wanted to do an OLS line, I'm going to comment out this line and add a different one. So this is basically telling our plus, ignore this one, go to this one. I would do geom smooth, and in the parentheses, I would say method equals LM. So in R, if you've taken any other R classes, especially in statistics, you would know that a linear model, which is its basic function is ordinary least squared regression, is represented by LM. So if I say geom smooth and I want the method of it, that to be LM. Now you can see I have one line for the entire plot and it's blue. And then I have this kind of gray area around it. I could ask, what do you think the gray area is? But I'll tell you right now, those are the standard errors of this line, which is a type of statistical, like, surety in basic terms. How sure are we that that's the line? Well, it's the blue one, but we have some unsurety there. So if I want to get rid of those, I would just say SE equals false. And so now I just have the blue line. I'll be honest, I hate that blue. That blue is very ugly. So I can then say color, and I can determine what the color of this line will be. If I want it to be, I can put quotation marks and say something like black or purple. I know by default that this purple is also quite ugly. It's very vibrant, but I could do that. What if I wanted different lines for each of these different species? We have to think about where we would put that determination, because if we want something by species, that means we want it to be an aesthetic mapping. We would want it outside of, we would want it inside of an AES bracket, because we would be telling them this is determined by a species. So I can either put it here, anything you put in your ggplot. I don't think you can see my highlight, by the way, very well, but in these first two lines, anything in aesthetics here is the same aesthetics for the entire plot. So if I put, let's say color equals species here, it would be applying color equals species to geom point and geom smooth, which I'm okay with, but there are instances where maybe you would want the color to just be on geom point and not geom smooth. So let me explain a little bit more of what I mean by that. I'll exemplify this. So I can do here, after this Y, I can do color equals species. And so now you can see I have 3 different trend lines for the 3 different species. which is really cool. It's exactly what I wanted. It's giving the same color to each same species. So the Adelie is pink, or pink geom points, or coral, with a coral trend line. And so that's actually really nice. I can learn a lot from this graph. What if I just wanted color species to just be on the geom smooth? I don't want it applied to geom point. I would need to remove it from the global aesthetics, because remember, anything in ggplot is the global aesthetics. And I would have to add aesthetics to the geom smooth. So here I would do comma equals mapping equals AES. And here I would have to say color equals species. Does anybody have any questions on the differences between these AES functions between different geoms? I think we're all good.
I actually have a question.
Yeah,
how do you divide the points so that like you have the line per species again?
So that is basically by defining an AES. So AES is aesthetic mapping. If I want something that I'm doing like a geom point or geom smooth, if I want it determined by a different variable. So in this case, I want my geom smooth to be separated out by 3 different species. I would have to say color equals species. I think I can also do group equals species just to show you the difference. Yeah, so in this case, group would be saying divide this, but don't actually make them different colors. So I could also do group equals species, comma, color equals species. And this would, species. This would be saying group this by species and color it by species. Every time you color it, it's implicitly saying group as well, but I think that helps exemplify it a little bit better. So yeah, instead of just making, hey, make this all blue, we're saying make different colors for these different groups. And again, I can also put this up here in global if I want the colors to also be separated on these dots. Actually, that's what I'm going to do because I think it helps the reader understand, you know, is this dot green or is this dot pink? We don't know. So I'm going to remove aesthetics from here. And you can see when I pasted that, it got a little funky and I don't like it. I'm very picky about my code formatting. So I'm going to do Control-I, which will format that for me. Put them all in a nice line. And so I'm pretty happy now with what this looks like. I think it looks nice. I think there's a lot we could do with it visually, like not aesthetic wise in terms of aesthetic mappings, but in terms of I want this to look nicer. So one thing we could do to make this look nicer is add a theme. So to add a theme in ggplot, we would do a plus sign and now add a next line. And we can add theme underscore. And then here's where we would determine which theme we want. If I click tab, it should give me a list of themes that are pre-installed. And I highly recommend that you look through these themes and find out which one you like best, because now this is all very personal. I tend to do theme minimal a lot. So let me show you what theme minimal looks like. So theme minimal keeps this back grid so you can kind of follow it, but it gets rid of all these lines. It gets rid of a lot of things. I could also do something like theme BW, which is theme black and white, which surprisingly isn't going to get rid of the colors in the plot, but it will get rid of the colors outside of the plot and make everything in black and white. I'll leave it there because now I actually want to add labels. I think flipper length MM would not look good in a final project report, for instance. It would not look good in a journal article. It would not look good in a PowerPoint. So now I want to add some labels to this. So to do labels, you can do another plus sign and now add another line. You can understand now why I said that after every plus sign, I like to do a line break, because this can get really long. There's some of these plots that are like, 20 lines long. And after my plus sign, I'm going to do a function called labs. Labs is actually really kind of straightforward. In labs, I can put a title equals, and quotation marks. So anything I want to add, I would do the name of what I want to add. And then in quotation marks, I want to say, let's see. Let's put like a question there, like how does flipper length relate to bill length? And maybe underneath that, I want a subtitle and say, this is something a lot of people do, and I don't know how I feel about it, but like a study of penguins. And then I want to rename my, so right now I've like, well, instead of just saying I've done something, let me show you what I've done. So I've added a title and a subtitle now, but I haven't cleaned up my axes labels. So bill length MM and flipper length MM are not, as I said, super great to look at. So I can do Y equals quotation marks for my Y-axis and X equals quotation marks for my X-axis. So for the Y, I can say, sorry, Y is here, which is bill length. So let's type bill length, and then in parentheses, the measurement, which is millimeters. And then for X, we have flipper length. So I can say flipper length, spelling. There we go. So you can see I've relabeled these axes. I just want to take a second now and see, is everyone following okay? Have I just gone at 1,000 miles per hour? Okay, I've got a thumbs up. I've got a shaking head yes. Good, okay. I mean, right now you're just following me, so it shouldn't be too bad, but I never know because I can't see your screens. Okay, and then I can actually add a caption as well. So maybe, maybe I'm using multiple data sets in my final project report, or each data, I have one data set, but it's got like multiple data frames or something. I can add a caption to say something specific down in this right corner is where it would go. So I could say data equals Palmer penguins. So you can see there's all these kind of little labels you can add to make life easier for the reader. I could rename this from species. I could remove just that it says species there. There's a lot that we could do here, but I think this is looking pretty good. One other thing I want to do is show you how to get even more themes. So I'm never fully satisfied with these ones. So there's another package, which you would have to download. You don't have to download it though, called install packages, GG themes. Most ggplotting packages are going to be GG something in their name. So I would install GG themes. I'm going to comment out that line so it doesn't get run. And I'm going to say library GG themes. So if I say library GG themes, now I should have more theme options here. So you can see where the theme here is coming from because it's highlighted over here on the right. So there's ggplot2, but then there's also GG themes now. So if I want to take the theme from the Economist magazine, I can just steal it and apply it to my plot. Stealing is a very hyperbolic word, but you can see now it changes the way that my plot is made. You could do this in base ggplot as well using theme options, but you could also just say theme Economist and get this kind of nice plot. There's a lot here if you just keep looking through the themes, and I suggest, as I said, that you look through the different ones. Like 538 is a website that has really great plots. Look through the different ones and see what you kind of lean towards, what you like. Okay, that was a lot. Now we're going to go on to mapping. Instead of 2 quantitative variables, let's move on to mapping 1 categorical and 1 quantitative. So what I mean by this is I have a categorical variable like island or species. I want it on an axis instead. So let me say 1 quant, 1 categorical. So I could do what we've been doing. I could say ggplot data equals penguins, mapping equals AES, X equals species this time, Y equals, let's look at body mass now. Body mass G, and then plus geom point. So this is the basic version of what we've been doing. However, we have that issue of overplotting that we talked about earlier. We could do GeomJitter so we can get this plots outside of this one line, but really, if I want to look at this, what I'm actually looking at, or what I'm actually asking often is what's the distribution of these variables? So the first thing I can do is a box plot. So instead of a geom point, I can ask for geom box plot. And I think that's a lot more useful. I can see, if you don't know how to read these, they're often called cat and whisker plots in elementary school. And so you have your, I believe it's the median, not the mean. You have your third quartile and first quartile. Yeah, so it must be the median. And then you've got kind of the min maximum points, excluding outliers, which would be here. I think this looks pretty good. What if I wanted to make, instead of having these black for Adelie, black for Chinstrap, black for Gen 2, what if I wanted to color them by species? Does anybody know where I would put that?
Inside the AES.
Great, thank you. I think that was Jinro. So color equals species. So that's nice. Now I have 3 different colors. If you wanted to change the white part instead of the black part, that would actually be fill. So color is usually the outline. If you want to do the inside, that's called fill. That's kind of one that a lot of people just learn by trial and error because it's hard to remember. But there's color and there's fill. So it looks pretty nice. However, I want this to look more like a density plot. Like I actually want to see how many values are here. Another alternative that I can do is called like a violin plot. So I'm going to make another one here, and this time I'm going to copy and paste it because I don't want to take another minute to type that. And instead of geom box plot, I'm going to type geom violin. And now I can see the different distributions of, Adelie penguins. Most of them are around 3,500 grams, I would say. And it tapers off in this way. Chinstrap penguins, there's a lot here, but there's, a few on the tail. I can do also one more, which you can probably write the code for, but it's another package, so you might not want to do it, which is called ggplot2. So a bee swarm plot is kind of like a geom point that we did earlier, but it's arranged as if it was a density. So let me explain what I mean by that. ggplot2. So I'm going to load that package that I already have downloaded, and then here it's geom quasi-random. Quasi-random. And then because I don't have anything to fill here, these are all just outlines, I would have to say color equals species. And so this kind of looks like the geom point that we learned earlier, but it's arranged as if it was a density curve. And so it's a really useful tool for specific instances. You don't have to download it, but I'm just showing you what's available. Let's say though that, I've seen, I can click through my plots like this. I've seen this plot here and I say, what's going on with Chinstrap? Could it be that the sex of the penguin is making this look very, I don't know, that doesn't look normal. Can I add this? Can I look at this by gender or by sex specifically? This is where facets would come in. So if I want to facet my violin plot, let me explain what that means. A facet is basically where you take a plot and by another variable, you make more than one. So you divide the data by, in our case, we're going to divide the data by sex. So we're going to have the female and the male plots. And then within that, we do all of this. Sounds complicated, but it's actually extremely easy. So after geom violin, or after whatever your last line is, you can add a plus sign and do something called facet wrap. So facet wrap is basically, we only have 2 here, so this isn't too complicated, but let's say you're doing something by state. You have 50 states. facet wrap will take all of the states and arrange it by however many rows or columns you want. So if you want only 2 columns, it'll wrap it around, kind of. That's why it's called facet wrap. But we only have 2, so it's not terrible. And then here we're going to learn a new R operator, which is a tilde. I feel like I mentioned this last week, but that was in terms of R Markdown when we were crossing things out, that was using a tilde. In facet wrap, or in R specifically, tilde means as a function of. So what I'm basically saying here is tilde sex. I'm saying facet wrap this plot as a function of sex. So if I run that, I'm going to get 2 separate plots. Well, okay, sorry, 3, because I forgot there was NA in this plot, or in this data set. So we've got female, we've got male, and then we've got an NA category. So these are the people measuring the sex of the penguin, for whatever reason, didn't know the sex of the penguin. So we've got some values here, but we have female and male. Generally males, especially Gen 2 penguins, males are a lot bigger. And we can see we've still got these very little weird shapes, but they're semi-normal looking. We also have a different, let me just open another one. We've got a different one called facet grid. And what facet grid does is instead of taking one variable and wrapping the facets around the one variable, it's going to make a grid of basically like Y would be one variable and X would be a different variable. So let me, I think I just say rows equals, I haven't done a facet grid in a while, rows equals island, and then calls, yeah, it's calls equals sex. Let's see if that works or it gives me an error. No, it does not. Okay, so in this case, I'm going off the book. And so now I'm going to type question mark facet grid to find out what I'm doing wrong. I think this is useful for everyone to see. So facet grid forms a matrix of panels, great. Rows and calls, I think I might be missing quotation marks. But if I scroll down, that's what it is. Okay. I have to do island as a function of sex, I think. Maybe? No. Okay, yeah, there it worked. Okay. So instead of rows and calls, this is, you have to do, instead of just a function of sex, you have to do Y as a function of X. And so now we can see we have sex on one side and the island on the other. And I think this actually shows us some interesting things because we quickly learn on Torgerson, Adelie is the only penguin there. On Bisco, there's both Adelie and Gen 2 penguins. Pretty interesting. Adelie seems to be everywhere. Okay, now I'm going to move on to bar plots, which I would say are also a version of mapping a one quantitative and one categorical variable, but more in the fact that when you're doing bar plots, you're generally doing like a count. So, so instead of mapping it onto a quantitative variable, which you could be mapping it onto a mean or something like that. You're oftentimes just looking at the entire count of the data. So let me show you what I mean by that. So let's do ggplot penguins. Oh, I just did a quick thing and didn't explain it. So instead of typing data equals penguins, I can easily just write penguins because I know the first thing that ggplot wants is going to be the data. So I can say ggplot penguins. It's often useful to write data equals so you remember what you're giving it, but you can skip that if your fingers are tired. I can then do mapping equals AES. I can also just get rid of the mapping equals AES. So like when I personally am writing this, I usually just write penguins AES. You can do it either way. I'll probably switch back and forth here, but it's useful to know that you don't have to write all of the details. Okay, back to the box plot. Here, I'm going to put an X value, X equals island. And then I don't actually have to put a Y value because a Geom bar is going to count the amount per island for me. So let me just explain that. Geom bar. If I run this, you'll see it's going to automatically get the statistic of what's the count of these over these islands. It's pretty useful. Let's say I wanted to add another variable here. Let's say I wanted to disaggregate this by sex, like we just looked at. If I wanted to disaggregate this by sex, I would say fill equals sex. And remember, fill is when you're like coloring in something rather than determining the outline. And here on Geom bar, if I just do it like this and leave it blank, it's going to make a stacked bar plot. Sometimes you want that. Sometimes you actually want to compare within. So this would just be stacked. So I'm going to write stacked bar plot. Boot. But I don't want that. I'm going to comment out that line and I want to do Geom bar. And here's one that like you either remember this or you look it up every time until you remember it. Position equals dodge. So position would be saying, where do I want these bars at? And I'm saying, I want to dodge these from each other, which means don't stack them, basically. So we can see here now we've got the count of each sex on each island disaggregated and like compared next to each other. So I can see on all of the islands, there's more females than there's males. I'm not a penguin scientist, so I don't know why that would be, but I think it's interesting. In other instances, I'm not going to go too deep into this, but I'll just give you a word of warning. If, for instance, you want to get an X and a Y to do a bar plot. So let's say you've done some cool calculation, you've got the mean or something like that, and you want to say Y equals mean. Well, Geom bar isn't actually going to know what to do with that. And so you'll actually need to use Geom call. So I'm just going to write Geom call for when you want to set a Y aesthetic. That's just for you in the future. We'll probably use that in the coming weeks when we learn dplyr, because we might do some cool calculations or manipulate the data in some way, and then we have a value that we want the Y to be set at instead of ggplot counting things for us. Okay, now finally, we're going to talk about one quantitative variable. So this would be like where you have, as I said, one quantitative variable, like flipper length, and you want to see how many of the penguins are in what hump. And so this could be a histogram, like I mentioned earlier. It could be a density plot. And so let's do both of those. So we'll first do a Geom histogram. And then after that, we're going to do a Geom density. And then I'll preview after that, we're going to do a, what's it called? GG ridges, that's what it is. So Geom histogram. Let's talk about how the flipper length looks like across our data set. So inside of a code chunk, we'll type ggplot, penguins, AES, X equals flipper length. So just like these bar plots that we did above, here we don't need a Y aesthetic, because what we're asking is how, like, what are the counts across these different flipper lengths? So it actually, a bar plot is actually quite similar to a Geom histogram, because we're asking R to do the work and calculate basically what these look like. So I can type Geom histogram and I'll let it autocomplete. And we can see flipper length is the name of the variable. Now we can see this is a histogram. What this is telling us is between each of these little bins, it actually Sydney did a really good job earlier because she mentioned binning. We have this continuous variable and we want to kind of put things into similar values. And so we're putting them into these bins. we're saying within those two, there's this many. Within, it's hard because I don't have very good labels pre-generated by this plot, but within, I don't know, 190 and 192, there's almost 30 values. Super useful. What if I wanted to disaggregate this by species? Because you can tell we have multiple, oh, my words are gone, multiple humps basically here. So if we wanted to disaggregate this by species, it would be the same thing we've done before. We could say fill equals species. Semi-useful, we have an overplotting issue. If we want to deal with that overplotting, here we could say alpha equals 0.5. And these are just all different ways. That's not super useful though either, to look at this data. I personally don't love histograms, but if I wanted to determine how big my bins are, so how wide this is, I could say I want only 5 bins. So I could say bins equals 5, which is going to make very wide bins that are not particularly useful. If you noticed, I completely lost that second high point in the density, which probably isn't great. Instead of saying the number of bins, I could also say the bin width that I want. Bin width equals, and let's just leave it at 5. So I want all of my bins to be 5 points wide. And so you can see now between 180 and 185, basically, or something like that, there's a bin. And so you can determine how big you want your bins. As I kind of mentioned, I don't love Geom histograms. I actually really like density plots more than that. And that's because density plots do an automatic smoothing. So if you remember Geom smooth earlier, Geom density is going to do a density line around this so that we can get the general sense of the distribution without dealing with these silly bins. So what does that mean? Well, let's play with it. So ggplot, penguins, you're all gonna get so good at typing this out. X equals flipper length mm, then Geom density. So this looks very similar to that first plot that we auto-generated with Geom histogram, but it's already smooth for us. So we can get a very good idea of what the average distribution looks like. I can do a Geom fill here too. Say fill equals species. And with this one, especially if I do the alpha, it's actually more useful, because I can see where the species high points are at, and they're overlapping, so I can actually see the inside of the distribution basically. So if you remember from a while ago, Gen 2 definitely has the longest flippers. That fact remains. One other one that I quite like is ggridges. This one also comes from an external package. There's a lot of external ggplot packages that add cool functionality to ggplot, like gganimate, for instance, lets you make animated plots. ggridges, library ggridges, will let us do, okay, I think it's what is it? Geom. Sorry, I'm looking on my other screen to see what it's called. Geom density ridges. There we go. So Geom density ridges. That's why I did not load the package. So now that it's loaded, I can actually find Geom density ridges. There we go. So you can see there's a function called Geom density ridges from the ggridges package. And the one different thing you have to do here is you actually have to set your Y value. So I want my Y value to be species, and you'll see why in just a moment. So what this does is it basically does what we just did, but it makes them kind of stacked on top of each other. So you can see a lot of different ridge plots against each other. So whereas this one here, they all had the same starting Y value, and you could measure their density. On this GG ridges, you're not actually measuring their height because you know a maximum density is going to be 1, but you're able to compare across penguins quite well. And if you have a lot of things you're trying to compare across, this is a really great way to do it. You've probably seen a plot like this in something like the New York Times. Okay, that was a lot of plot types. I'm just going to go into now, in this last 10 minutes, different things you can kind of add on here. So the first thing is scales. So in a plot like this, I'm just going to go off this one because it's the last one I did. If I want to change the colors here, you know, these are the same default colors. Everyone knows these are the default ggplot colors. Maybe I want to do something fancier. I can do scale, and then I want to change the fill value. So it would be scale fill. And then let me scroll down. I want scale fill. I think it's discrete, but I think it's manual. Hold on. Yeah, scale fill manual. So if I want to manually fill these colors here, I would do scale fill manual, and then I would type, I'm just double checking. I think it's value. Yep, values. Okay. Values equals, and here's where I would do whatever colors I wanted. So if you remember from the beginning of the class, I did a C, which means make these things into a vector. So I want a vector of colors. The first color I want, anybody have a particular color they want in here? Doesn't seem like it. Let's do some purple. Let's do some pink. And let's do some gold. So these are all preset R colors. I'll put a link in the chat for other ones. You can also just do hex values. So let me put that link in the chat. So you can Google this. I just have it pre-saved on my browser, as I mentioned. So instead of pink, I could have said deep pink 4. These are all preset, but as I mentioned, you can also do hex values. So if I wanted specifically this hex value, I don't remember what this stands for. Hex values are 6 letter and number combinations of unique colors. So you can go online and you can pick your exact color that you want. That looks terrible together, but you get the idea. You can also do other types of scale fills. So that's how to do it manually. Let me comment out this line. If I want to do something like use a pre-generated color scheme, I could do scale fill and then look at the other options that are given to me by default. So one is scale fill colorblind. Making colorblind plots is actually really important for the accessibility of our plots. This doesn't look bad by any means, but it's colorblind friendly. That's a really great way to change your color scheme. And I believe on our homework coming up, we have a colorblind test. So remember how to get to scale fill colorblind. You can also do something like scale fill. Let's do the Viridis, I think it's called. Viridis. I never say it out loud. I just look at it. So there's some predetermined plot colors called Viridis. And these ones are really like purpley and yellowy and blue. They're pretty cool. I don't know why it's not loading though. Bin scales only support continuous data. Okay. They didn't like that one. Let's try the other scale fill continuous. You can tell I'm going off book, but that's fine. No. Okay, so discrete value supplied to a continuous scale. So that's why I would have to do scale fill discrete. You get the point. If I wanted to do something like a continuous scale instead, that's where Viridis would come into handy. Okay, actually, it looks like scale fill Viridis D. There we go. Okay. So as I said, Viridis does a lot of blues and yellows and purples. It's a really pretty plot tool, especially because if I pull this one we did earlier down to here, where we had a lot of different kind of things determined, if I wanted to color by body weight, I think think it was, no, it wasn't body weight, body mass G. What I could do here is I could add a scale, fill, viridis, probably B. No, probably B. That's boring, but you get the point. So here, the issue is that I have both a theme and a scale, and I think the theme might be overriding the scale, or it's just a very boring scale. But let's say I wanted to determine my own, because I'm doing like a bin scale of low to high value, I can create my own value that I want these to be between. So if I do scale color, that's why it was scale color, that was the difference. Scale color continuous. And I wanted to create my own, I could say low equals, let's do gold, because that kind of looks nice. And then high equals blue. And so I can determine what colors are coming in what direction. And if I want 3 colors, I can do a scale fill gradient. There's a lot of different options for customization here. And this is one of the reasons why I find ggplot so fun, is I'm really picky about colors. And in things like Excel, well, there's a lot of reasons why you don't want to plot in Excel, but a few of the reasons are it's really hard to customize these things. So we've talked a little bit about color palettes. We've talked about scale fill, scale color. I showed you how to do some manual ones. If I wanted to do something like remove the legend, let's say I just hate this legend and I want it gone, there's a lot of things you can do within theme. I mentioned earlier, this whole theme 538, all of these are you could do manually, but they're kind of saved in a title like this. I could also manually edit it. So if I do anything theme, there are, I'm going to paste another link to the chat. Yes, and I will upload the file to Canvas, Raphael, for sure. Here's just one cheat sheet that I use. There's a bunch of things you can edit with themes. If I want to hide the legend, for instance, I would say legend, I think it's legend position equals none. Let's try that and see if that works. Yes, so you can see I just removed the legend. Those are all tiny little details that I don't think need to be taught in class because they're all very specific to whatever you're trying to do, but I'm just letting you know there are things you can do and it's super cool. Okay, I like this plot. I want to save it now. How do I do that? After you run a ggplot, you can either save a ggplot as an object here in R. So if I wanted to do that, what I mean is I can say plot1 is this ggplot. I can run that and I'm not going to get any output here, but if I click plot1, the output would pop up. Then I can do something called ggsave. Ggsave is a function that saves a ggplot. What you need to know here is that we have to say the file name of what we want this to be saved as. File name equals, and then you can only use folders that are already created. But let's say I wanted to say file name equals images, because I have a folder called images. Remember, if you need to go backwards between your folder structure, you can do a ... But I want to say images, my first plot dot, whatever you want it. Most people are going to do a PNG here because PNG is really high quality. That's what I would suggest you default to, but you can also do a PDF. I still don't completely understand why that's useful, but a lot of people do it. You can determine what exactly you want your width to be. I could say like width 5, height 3. And then when I run that line, well, first thing you may realize is I didn't actually tell them which plot I wanted to be saved. So this is dangerous because by default, it's going to save my last plot that I ran. But I can also say plot equals plot1, which I should do. So that's how I'm going to do it. I'm going to say plot equals the name of the plot, but by default, it's going to go to the last plot that you created and it's going to save it. So if I click images, I click my first plot, it popped up in a different window. It's thinking. Is it working? I don't know. There we go. So important things to notice here as class is over is that the size of your text is determined by default in R, but if you put your width and height to be too small, all of this text can go off the screen. So there's a lot of kind of finicky work here where you have to make this large enough so that the text is large enough or not too large. But there's a lot that you can work with here. So before we end, for next class, if you want, you can review the ggplot lesson that I have on the class website. The only thing we didn't cover at all was how to combine two plots together, which you may want to do. If I hear more about that, we could work with that a little bit in the lab. It's actually really easy to do, but you just need to know how to do it. Besides that, let me click the schedule so we can all see this. So if you go to the schedule, we're in week 3 visualization. Before next class, you have a little bit of reading to do. As always, we do our reading between Monday and Thursday. So it's chapter 3 of the R for Data Science book, which a lot of it's going to be reviewed from the lecture, but that's good. You get to hear how a different person explains it, particularly the person who created the package, and review some of the things that I didn't cover for my own reasons. And then there's another article called 4 Big Data Viz Myths Busted. Kind of a cool article. It's pretty short, but it just gets you into thinking about what makes a good data visualization and how do I communicate what I want to my audience as a data scientist. So that's your homework for Thursday. The lab is not up online yet, but you don't need it yet. On Thursday, when you come to class, we'll work on the ggplot lab and you'll do a lot of hands-on work figuring out what the heck I just taught you in class today. I remember my first time learning ggplot, I was like, what? So I have a feeling that's going to happen for most of you. I'm going to stop sharing and I'm going to stop the recording. If anybody has questions, you'll feel free to ask.